In this video, the problem that we would like to solve is the following. If we have a point P in the xy plane with coordinates x1 and y1, and we know that the line that passes through that point has a slope of m, can we derive the equation of the straight line? So let's draw this here again. So here's our xy plane, and here's our point P1. If we just knew that the line passes through P1, we can't derive the equation because there's an infinite number of lines that pass through that single point. So we could have a line that goes through here, another line that goes like this, a third one like that, and so on and so forth. So just given a single point in the plane, we can't find the equation of the straight line. The same thing if we were given just the slope of the line. So we could have had a line like this with a given slope, or a line like this that has the same slope, or like this. So all these lines have the same slope. So just knowing the slope alone does not help us find the equation of the line. But if we were given the point and the slope, that would be sufficient. Or if we were to be given 2 points on the straight line, then that also will be sufficient, because using those 2 points, we can first compute the slope and then we can derive the equation. So how are we going to derive the equation? So the property of the straight line is that the slope does not change along the line. So for any 2 points that we pick, so let's say this is P1 and P2. So if we compute the slope of the line, so the slope of the line is the difference in the y coordinates divided by the difference in the x coordinates. We call that m. So slope of the line equals m, which equals delta y divided by delta x. If we have 2 points, it's the difference in the y coordinates divided by the difference in the x coordinates. So in our problem here, we're given that slope m. We know what that slope is. And we're given a single point P1 that lies on that line. So to derive the equation, we'll pick another point, a general point on the line, and we'll give it coordinates x and y. So the slope computed using P and P1. P1 is the point that we were given. We were told that the line passes through that point, and P is a general point with coordinates x and y that lie on the straight line. The slope computed using those 2 points has to equal the slope m that we were given here. So the slope computed using P and P1 is y minus y1. It's the difference in the y coordinates between P and P1 divided by the difference in the x coordinates, which is x minus x1, and that equals the slope m that we were given. So we can write this if you multiply this entire equation by x minus x1. So y minus y1 equals m times x minus x1. If we move y1 to the other side, then y equals m x minus x1 plus y1. Expand the first term, that equals mx minus mx1 plus y1. And we can rewrite that as mx plus y1 minus mx1. y1 is known, m is given, x1 is given, so this entire term is a constant. So we can write that as mx plus b. So this is the equation of our straight line. M is the slope. B equals to y1 minus mx1, But what does that represent on the line? So our equation is y equals mx plus b. If you set x equal to 0, then y equals m times 0 plus b, which means y equals b. X equals 0, so if this is our origin, 0 and 0. X equals 0, it refers to the y-axis. So on the y-axis, x equals 0. So we said here, if we set x equal to 0, y equals to b. It means that the place where our straight line intersects the y-axis, that is b. So b is the y-intercept. So this is the equation of a general straight line, y equals mx plus b. The constant term that's multiplied by x is the slope of the line, which we call here m. The constant term that's added is the y-intercept. It is the place where the straight line intersects the y-axis.